Okay, guys, now let's take a look at proportions. Before we were talking about ratios. What a proportion is, as simple as it can be, is simply just two equivalent ratios put together. What I mean by that, in walking you guys through what I mean, if I have the ratio 1 to 2 and set it equal to the ratio 4 to 8, because these two are equivalent ratios, remember we talked about fractions and we talked about these two fractions so many times in our fractions chapter. We saw them just written on top of each other instead. We know that these are equivalent, and remember we knew that because, remember, cutting a pizza into 8 slices, 4 of those slices is the same thing as cutting a pizza into 2 and then eating one of those, that they still represent the same amount of pizza, and that's why they are considered equivalent fractions. And so, like I said earlier, ratios and fractions are almost interchangeable in that you can use ratios the same way you use fractions, or really you can even write the ratio 1 is to 2 as the fraction 1 over 2, and 4 is to 8 as the fraction 4 over 8. And you can see that they are equivalent. Um, just because we've seen these so many times, but as long as the two fractions are equal, or I'm sorry, the two ratios are equal to one another, then that is a proportion. We say proportions out loud by saying this would be read as 1 is to 2 as 4 is to 8. And we know that that would be a true statement, that it's read almost like an analogy. A good analogy to think of would be something like up is to down as hot is to cold. What we're saying is the relationship on one side of that equal sign is equal to the relationship on the other side of the equal sign. So we know that 1 is half of 2, just the same way 4 is half of 8. But without having to think of any of those things, what your book shows us and introduces to us is a way to test to see if two fractions are equivalent to one another. And what it does is it takes these two ratios and we go ahead and write them as fractions. So 1 over 2, and then I'm going to rewrite the 4 is to 8 as 4 over 8. And it shows us that if we take opposite numerators and denominators and multiply those numbers, as long as we produce the same answer, then they're equal. So what I mean by that is when I cross multiply, it doesn't matter what side you multiply first, as long as you multiply opposite numerators and denominators. So over here, if I multiply 1 times 8, I know 1 times 8 would give me the answer 8. Over here on the other side, multiplying 4 times 2 also produces the answer 8. So because I get the same answer in both scenarios, this is definitely a proportion. So given an example in any other case, let's say I have the proportion written out that says, let's say 10 is to 15 as 6 is to, I don't know, let's say 10. Just something like that, just to kind of see the equivalence of the relationship here. Maybe looking at this, I'm not entirely sure if they are equal or not. So I need to take a look at that, and we can do what our book shows us. And it shows us that if we rewrite these, 10 over 15 equals 6 over 10. Still maybe having a hard time with seeing if these are equivalent or not, so we can just double check that. And it does not matter what side you multiply first. If I multiply, let's say I'll multiply this side first, just to be different from our last example. 15 times 6 gives me 90, and then when I multiply on the other side, 10 times 10 is 100. So therefore these are not equal, and so therefore this is not a proportion. So this next section that we're going over is we're just determining whether or not these are proportions or not. And if we don't produce the same answer, the answer is simply just no, they are not proportions. And that's what we're looking at, guys. In the nursing math class, you guys may be looking at this, and your book, I think, also shows us that anytime we have a proportion, let's just look at another one here. If I have, say, 3 is to 8 as let's say 6, let's say 3 is to 8 as 6 is to, let's just do 10 again. Okay, so if we're looking at this, maybe we're unsure. You guys may have looked at this and said, okay, there's no way. But maybe we're unsure. Guys, in my nursing math class on Tuesdays, your all's book also shows you that if you don't want to rewrite these as fractions, you can if it's easier for you. And instead of just multiplying opposite numerator denominator, you could, it refers to these inside and outside numbers as what's called the means and extremes. Means there in the middle, extremes on the outside. You could just do that. You could just multiply the two inside numbers and multiply the two outside numbers, and it would be the same thing had you have just rewrote these as fractions. And that's totally up to you. Guys, in my Monday class, your all's book doesn't show you this, but please know that that's also an option for you guys. I am kind of in the habit of using fractions, so I usually stick with this, the opposite numerator denominator. But do know that if you don't want to go to the trouble of rewriting these as fractions, you can always just do that. And again, it does not matter what side or which one you multiply first, as long as you're grouping together the two inside numbers and multiplying them, and grouping together the two outside numbers and multiplying them. It's the same thing either way. So if we did multiply 3 times 10, we know 3 times 10 produces the answer of 30, and that's, the outside numbers here, and when we're doing the means and extremes, so we still multiply 3 times 10. The inside numbers, or for those of you guys using the fraction method, inside numbers or the opposite numerator denominator, 8 times 6, we know produces the answer 48. So these are definitely not equivalent fractions. So we would go ahead and just say the answer again to that is simply just no. If I have the ratio, let's say 3 is to 4 as 30 is to 40, you may be able to look at this and see that yes, 3 is to 4, it looks like I've simply just multiplied both numbers by 10. So they are equal. In any case, you could just go ahead and still test it the way we have been. You could either, again, use the means and extremes. So means here on the inside, extremes out here on the outside. So no matter what, you're going to take 4 times 30, and then 3 times 40, no matter which method you're using. So 4 times 30 does give me 120, and 3 times 40 also gives me 120. So therefore, yes, these are definitely equivalent. So yes, this is a proportion. And that's all we're doing here, is just testing to see if they are proportions. So the first part of next week's quiz, well, not the first part, right after our ratios, I should say. The first part of our proportions, we'll do just that. I'll give you 2 ratios set equal to one another, and I just want you guys to tell me whether or not those are proportions. But we can use that method, that proportion method, if maybe one of those numbers in our proportion happens to be missing. What I mean by that, let's say I have a proportion that says this, and I'm just going to use the first example that we use today in our proportions because we are so familiar with those 2 ratios or those 2 fractions. If I said 1 is to 2 as x is to 8. Some of you guys may be familiar with x. It's commonly used when we're putting in an unknown number. If it just simply means I don't know what that number is, but I can solve for that x based on the rest of the information in this proportion. Remember what I said earlier, that proportions are read out loud to say 1 is to 2 as this, in this case, as x is to 8. So in other words, let's think about the relationship over here on the first side. 1 is to 2, well, 1 is half of 2. So therefore, whatever this number is over here must be half of 8. So, okay, so that's one that we could probably do in our head. We definitely know that this is going to be 4. And we also know it's going to be 4 based on the fact that we saw this proportion earlier, just a couple minutes ago. But here's how we can use that cross multiplication method to show us how to solve for x. What we can do is we can go ahead and do that. Go ahead and rewrite our proportion here as fractions. And I'm going to show you guys, I'm going to walk you guys through this really quickly, and then I'm going to show you guys a shortcut method, an easier method so that you don't have to do as many steps. What we're going to do is we're still going to multiply across numerators and denominators just as we did before, and I'm going to write down the answers that we get. Except what happens when you multiply 2 times a missing number, or in other words times x, since I don't know what x is, I have to simply just call that 2x, or 2 times x, because I don't know what it is, so I can't multiply it. So I'm just gonna leave it as that for right now. Then what I'm going to do, as I've done before, I'm going to set it equal to the answer on the other side. 1 times 8, we know, gives us the answer 8. So now what I run into is a little bit of kind of a pre-algebra problem, in that it says 2x, or in other words 2 times x, is equal to 8. Which again, in our head, we know, well, that's 4. 2 times 4 is what's going to give me 8. But let's pretend we don't know that. What happens in pre-algebra when I'm trying to solve for a variable, or what's called a variable, which simply just means an unknown number, where we've used a letter in place of that. When I'm trying to solve for x here, what I want is I want my answer to say x is equal to something, because then therefore we know what x is. It's telling me x is equal to this number. Right now it says 2 times x is equal to something. So what I have to do is I have to get x by itself on one side of this equal sign. That's the idea. Over here on the left side of the equal sign, it currently has 2 times x. So in pre-algebra, what we have to do, anytime we're trying to get rid of something on an x so that I can get x by itself, I have to do the opposite of what's being done. Some of you guys may have seen this before. What I mean by that, by the opposite, is since x is currently being multiplied by 2, we have to do the opposite of that. What's the opposite of multiplication? Division. So when I do that, and then vice versa with addition and subtraction are opposite of one another. We'll get to that later on. So what has to happen here, I'm going to go ahead and divide this by 2, because what that does, when I have opposite operations taking place here, 2 times x and dividing by 2, since they're opposite of one another, they cancel each other out, which leaves me with x over here on the left side of that equal sign. That's exactly what I want. But we have to remember what equals means. It means whatever's over here on the left side is equal to what's over on the right. So if I do something like divide by 2 on one side, I have to divide by 2 on the other side as well. And when I do that, it doesn't cancel anything out since I don't have the same number over there. Instead, I have 8 divided by 2, which we know is 4. And that gives me my answer. Now, and we could do that. We can set that up that way every single time. But I mentioned to you guys, I'm going to show you guys kind of a shorter method here. Instead, what I can do is, what we had was 1 over 2 is equal to x over 8. Instead, a faster way of doing that, because as you guys can see at the end of that problem just a second ago, we ended up with 8 divided by 2. And it'll always work out that way, where the answer to the opposite side of our x, so in this case 1 times 8 was 8, that answer divided by the number that's diagonally across from the x, dividing by 2 in this case, will give me my answer every single time. So all we really have to remember is simply just multiply the side that's opposite of our x first. So since x is here, that's why I chose to multiply 1 times 8 first. So multiply opposite of the x first, and then divide by the last number that we have left over. And that works every single time, and no matter what case. So let's say in this sense, let's just say a different number was missing. So let's say we have 1 is to 2 as 4 is to x. This time our 8's missing. But I'm going to show you how we can figure out why that's 8. What we do is we do the same thing we did a second ago. Go ahead and rewrite those as fractions. 1 over 2 is equal to 4 over x. But instead, our shortcut method says that let's locate our x. So we multiply the other side first. 2 times 4 gives me 8. and then we just divide by the last number. In this case is 1. And 8 divided by 1 we know is 8. So there's our correct answer there. Again, we know that just because we've seen this so many times, and we may be able to do that in our head, but it works in every single time. If let's look at some random ones. Let's say I have 3 is to x as, I don't know, let's say 4 is to 7. One that we may not be able to do in our head, because I'm saying that 3 is to some number as 4 is to 7. Hard to kind of do in my head what the relationship is between 4 and 7. So what we can do is we can go ahead and rewrite those as fractions. And we can go ahead and set this up by looking at my x. We find where x is, so I'm going to multiply the side that's opposite of our x. We know 3 times 7 gives us 21. Then I just simply take 21 and divide by that last number. So 21 divided by 4, and you don't have to write this out, I'm just showing you guys what I'm doing. 21 divided by 4 gives us a decimal, 5.25. And don't be thrown off if you get a decimal. That is an okay answer. Earlier when we were looking at ratios, when we were simplifying ratios, we did need those two numbers to be whole numbers, but we don't necessarily need to, our answer, when we're solving for x, x can be anything. It can be a whole number, it can be a decimal, not a big deal. It happens to just show us that that's what the relationship there is over on the left-hand side. So our answer here is 5.25. Doing one more of these to show you guys this will work every single time. And this will help us as we get into our next section here. If we have, let's say, the proportion, let's say 5 is to 17 as, let's say, x is to 20. Again, something that may not be as easy to do in our head, so we're going to go ahead and set this up. And now again, remember, for those of you guys if you're using that means and extremes method, that's totally fine. It's just, remember, it's just that your x happens to be located in the means area, so you would just multiply by the extremes first, then divide by 17 if you're doing that. But again, I'm just used to the fractions method, so I go ahead and set these up as fractions. And then again, since x is where x is, I'm going to multiply the other side first. So I'm going to take 5 times 20. We know 5 times 20 is 100. So then I'll take 100 and divide that by 17. 100 divided by 17 gives us some crazy long decimal, but we can just round that off. It gave us about 5.88235. I'll just go ahead and round that off to 5.9. Much easier to look at. Remember, guys, I told you guys in week 1 that rounding, the only place I'm going to be real specific on your rounding is on the rounding section. If somebody answered that as 5.88, I would definitely not have marked that wrong. That's okay. I'm more concerned with the fact that you guys are doing the calculations correctly at this point. Later, we'll talk about, how I want you to round, but right now I just want to know that we're doing the right steps. So that's how you would solve for a missing component in part of a proportion, which will help us as we get into our next section as we look at conversions. What we can do is we can use that proportion method to help us solve for measurements. When I am unsure, let's say we have one we can do in our head. Let me give you an example that's not on your all's equivalent sheet. This is where we will utilize those equivalent sheets that were given out in class today. I'm gonna do one that we are already pretty familiar with, just for the purpose of introducing this to you guys. But let's say I have 4 hours. 4 hours, and I want to know what this is in minutes. This is something we will actually touch on a little bit later when we talk about IV dosages. I want to convert 4 hours into minutes. Now, where this proportion method comes in here, when I have hours and I want to convert it to minutes, this is what's considered an unknown. I don't currently know what the answer is, but I do know something about hours and minutes. And thinking in our heads here, how many minutes are in an hour? Let's think about that for a second. We know that there are 60 minutes in every hour, correct? So that's what we do know about hours and minutes. We know that 1 hour is 60 minutes. So what I can do is I can use this proportion method to figure out, well, how many minutes do I have if I have 3 hours then? And now I know there's a lot of these that we may be able to do in our head. You guys may be looking at this and saying, oh, that's 4 times 60. Okay, easy, that's 240 minutes. If you did that, you're totally correct, and you definitely don't need to set up a calculation every single time. So don't think you need to do that. In fact, Nurses, your all's book shows you guys that anytime you're converting from the larger unit to the smaller one, all you do is multiply. And then the reverse if we were going in the opposite direction. And so we'll do some where I can show you guys what to do if we're doing it in our head. But for now, I just want to show you guys how you can use that proportion method. To use that proportion method, what we're going to do is we're going to look at this, the question itself, this right here, 4 hours and blank amount of minutes. This is what's considered the unknown. This is what I don't know. I don't know how many minutes are in 4 hours. The second part down here, the 1 hour equals 60 minutes, that was something we did know. This is what's called our known. And what we can do with that proportion method is we can set these two things equal to one another in order to be able to solve this equation. So let me show you what I mean. Let me get these things out of the way here. So what I mean by that is we're going to take the question, 4 hours, and I'll just abbreviate for, space purposes here, 4 hours and X amount of minutes. Those were both part of the unknown, so I need to list those together in this proportion. I'm going to list those as 1/2 of the proportion. Then what I'm going to do is I'm going to set it equal to the other side, which was our known, which said we did know that 1 hour was equal to 60 minutes. And what we could do is we can just, the same as we've done before, we know that this is where our X is, so we simply just multiply the opposite side. 4 times 60 gives us 240. Dividing it by the last number, 1, 240 divided by 1 is 240 minutes. So we can use this proportion method to solve for these unknowns anytime. There's only 2 rules to remember when we're setting up these proportions on our own this way, and that is this. 1, our known and unknown must be set equal to each other. So you can see that's what we did here, that we took the unknown, which was again the question, that's what we have right here. The unknown had to be one side of our proportion. So 4 and X have to be on the same fraction. Whereas our known, our 1 hour to 60 minutes, was the other side. So rule number 1 for setting these up on our own is that we have to set it up as known equal to unknown, or unknown equal to known. It does not matter which side you put the unknown on and the known. The reason why I say that, why it doesn't matter, think about this for a second. Let me see, if I just wrote this down, let's say up here at the top, 2 plus 2 is equal to 4. Is 4 equal to 2 plus 2? Oh, that's horrible handwriting, sorry. Yes, it is. It does not matter what side of the equal sign either one of those go on, and that's the same case here. But the only other rule we have to make sure that we follow is we have to make sure that however we set up one side, the units match over on the other side. So you'll notice that on the screen here, I set up the unknown. I wrote down the unknown down first. And I wrote it as 4 hours over X amount of minutes. Because I wrote hours on top of minutes of that unknown side, that's why I chose to write hours over minutes over on the other side. Let's say we were doing the reverse of this exact same question. Let's say I didn't even know that we had done that calculation. And my question we have 240 minutes, and that to me just makes more sense in hours, so I want to convert that to hours. Pretending like I don't know that the answer is 4. Although in our head we know that the answer is 4. Let's see how. If I wrote that unknown down first, 240 minutes and X amount of hours is my question. That's my unknown. That's what we've written down here. That's It's my unknown. My known will go on the other side. Again, it's the same known because we're still comparing hours and minutes, except now when I set this up over here, I have to put 1 hour on the bottom and 60 minutes on the top because I have minutes over hours. See, I have minutes over hours on the first side, so I must have minutes over hours over here on the other side. So when I go to solve this, and let me get those goofy arrows out of the way. When I go to solve this, again, because x is located here, I'm going to cross multiply the opposite side. 240 times 1 gives me 240. And then taking that answer and dividing it by my last number, 240 divided by 60 is 4. So the answer then is 4. And that will work every single time as long as we're following those same 2 rules. Unknown, set equal to known. Make sure your units match up. And there may be some, like I said, there may be some that you can do in your head. Let's practice a few from using your equivalent sheet. Let's say I have the question, let's say 6 teaspoons is equal to blank amount of milliliters. That's what that abbreviation, those abbreviations are there. And your abbreviations are on the bottom of that equivalent sheet. So if I use abbreviations that you're not sure what I mean, just check the bottom of that sheet there so you know what I'm talking about. 6 teaspoons equals blank amount of milliliters. When you look at that equivalent sheet, the very first, when I'm looking for a relationship between teaspoons and milliliters, I'm looking for a known, an equivalent, on that sheet that contains both teaspoons and milliliters. And the very first thing you guys see there, it says 1 teaspoon is equal to 5 milliliters. Well, some of you guys may be thinking, okay, well, 1 teaspoon is equal to 5 milliliters, so therefore 2 would be 10 milliliters. 3 teaspoons would be 15 milliliters. So you kind of see where we're going here. You may be looking at this and saying, well, then 6 teaspoons would be 6 times 5, well, that's 30. And that, again, is totally fine. You don't have to use this setup method, but this is just for those that really want to see the setup. Once you get these equivalents memorized, which I want you guys to have memorized by the midterm. You don't have to have them memorized by next week. You will have to have these memorized by the midterm. And these equivalents, guys, we will use these through the final. So you will need to have them memorized for that. You'll see them pop up again maybe on a later test, and you'll definitely see them come up again on the final. So these are some things you definitely want to get to know, as you will also see them in a lot of your later classes as well. But for those of us that want to see that setup, again, we're going to set up our unknown. I'm just in the habit of writing the question down first. It doesn't matter, again, which one you put on the left side and which one you put on the right. But I just write down the unknown first, 6 teaspoons and X amount of milliliters. So there's my question, my unknown. Whereas my known, this, is going to go over here on this side. But again, because I want to match up teaspoons over milliliters, just like I had set up over there on the left, I want to do the same thing over here. So my 1 teaspoon goes on top, my 5 milliliters goes on the bottom. And that's where we then multiply. 6 times 5 divided by 1, my last number there. 6 times 5 is 30, divided by 1 still gives me 30. So that's where that answer came from. Like I said, if you do them in your head, perfect. There is no rhyme or reason as to why you would have to set that up. This is just if you want to use that setup, if that helps. Some people just like to see the setup more so than they like to do it in their head. In the nursing book, it does explain, it shows that in that type of question, it says in your book if you're going from the larger unit to the smaller unit, and the way that I know that that's the larger unit, think about your known. 1 teaspoon is equal to 5 milliliters. Well, in this particular known, what I know about teaspoons and milliliters must be pretty dang small if 5 of them fit into one of these spoons. So in thinking about that, if you picture a teaspoon that you have in your baking drawer at home, I know that's horrible, but that's a spoon. If you picture a teaspoon, 5 milliliters will fit in there. 1, 2, 3, 4, 5. So milliliters must be pretty small if they fit into that spoon. So anytime you're looking at your equivalents there, whichever one is the 1 is your larger unit. And so that's something that you guys could just memorize too. Anytime I'm going from larger to smaller, so that's what's happening here. I'm going from the larger unit of teaspoons to the smaller unit of milliliters. We multiply. We multiply by the known. So we would just take our 6 and multiply it by the 5. Obviously, we wouldn't multiply it by the 1. I'm meaning the number that's part of that equivalent. So 6 times 5. Whereas it would be the opposite if I was going from smaller to larger. So let's say we have, I'm going to give you guys a smaller to larger one. Let's say I have a question that says 20 ounces is equal to blank amount of cups. So I'm going to show you guys both methods that we can use here. Those of you guys that are trying to use the method where we just do it in our head, we use our known for ounces and cups. If we look at our relationship for ounces and cups on our equivalent sheet there, it does say that 1 cup is equal to 8 ounces. So I mentioned to you guys just a second ago that if I'm trying to figure out which one's larger and which one's smaller here, the 1 is always your larger unit. So cups are larger than ounces. When we're comparing these two units, cups are bigger than ounces, since 8 of them will fit into that 1 cup. Here's one cup here. And our ounces, we can fit 1, 2, 3, 4, 5, 6, 7, 8 ounces into 1 cup. So therefore, ounces are our smaller unit here. But in the question, it's asking me to convert from ounces to cups. So the smaller unit to the larger unit. And anytime we're going from the smaller unit to the larger unit, in this case, we are going to divide. So if you're just trying to remember that, smaller to larger means to divide. In this example, we would simply just take 20 and divide it by 8, and my answer that produces is 2.5. But for those of you guys who don't want to have to remember the difference between smaller and larger, larger and smaller, that might be confusing for us. Instead, follow the same routine we've been looking at. And that is simply just look at your known and unknown. Write them equal to each other, and then we'll use our cross multiplication method. So I'm going to go ahead and, as usual, I'm going to write down the unknown first. The question says 20 ounces and X amount of cups. My known, again, was 8 ounces in 1 cup. And I chose to put the ounces on top since I had ounces on top over on the other side. Don't forget that. And so now, following my method for solving proportions, I'm going to cross multiply the side that's opposite of my X. 20 times 1 gives me 20. And then I'm going to divide by the last number. 20 divided by 8, again, is 2.5. So it doesn't matter which method you're using. Again, that's the beauty of math, that you can find the same answer a number of different ways. So you can either use that smaller to larger method, or in the larger to smaller method, or you can use this cross multiplication method. Either or, it doesn't matter. Like I said, those that are using this setup that we have on our screen here, this is usually for people who would rather have some type of formula to set up so that they know that they do it the same way every single time, and there's no having to distinguish between having to distinguish between smaller, which one's the smaller one, which one's the larger one, and blah, blah, blah. You don't even have to think about that when you're doing this setup. So as I normally send you guys review videos, the review videos that I sent you on this one does go over both methods. I do have a video strictly on the size method, is what I have it titled, meaning that where we're memorizing larger to smaller means to multiply, smaller to larger means divide, and then I have a separate video that just shows you guys this proportion method. So practice a few more of those in those conversions. Again, get into the habit of getting to know those equivalents. I do want to show you guys one more just to make sure we've got this down pat. Let's go ahead and let's look at 2 more actually. One more that's one of each, where we're going from the larger unit to the smaller one and vice versa. So if I had, for instance, let's say I have 6.5, so 6.5 pounds, and I want to know what that is in ounces. Let's try that one. 6.5 pounds to blank amount of ounces. If you guys want to pause this and practice it and try to do it on your own, definitely go ahead and do so. but I'm going to go ahead and start working on that now. For those of you guys that are using the larger to smaller method, or again, the size method, this unit of pounds is larger than ounces. And the reason why I know that, again, because I look at my equivalent sheet, and my relationship for pounds and ounces says that 1 pound is equal to, and that's a 1, is equal to 16 ounces. So again, remember, whichever one is the 1 is your larger unit. So here I'm going from that larger unit to smaller. So if we have that memorized as larger to smaller means to multiply, that means I'm simply going to take 6.5 times 16, and my answer is 104. Should get 104 on that one. But for those of us that would just rather see the setup and don't want to have to worry about that larger to smaller stuff, instead we can just set this up. Don't worry about that decimal as part of our proportion. All we do is set that up as 6.5 pounds over X amount of ounces. Over on the other side, I'll set it up as pounds over ounces as well. So 1 pound for my unknown and 16 ounce. I'm sorry, for my known, not my unknown. Duh, Ellie. 1 pound over 16 ounces so that it matches the pounds over ounces on that unknown side. That's what I was trying to say there. And then what we'll do is, just as we've been solving our proportions, I'm going to cross multiply the side that's opposite of my X. 6.5 times 16 still gives me 104, divided by 1, as we know, is just 104. So no matter which method we use, we get the same answer. Doing one more of these, just to make sure we've got this down pat. Let's look at one where we're going from well, I'll show you guys. We're going from, let's say we have 500 milliliters, and I want to know what that is in cups. Okay, so another one where we're looking at cups, but in this case, since I'm converting from milliliters to cups, I'm going to have a slightly different known here. If I'm looking at my chart, my relationship for milliliters and cups, you guys may find that it does say that 1 cup is equal to 240 milliliters. Okay, I know we had earlier 1 cup was equal to 8 ounces, but since we're not converting with ounces here, we're looking at milliliters. This is the known that I need to use here. So for those of you guys using the smaller, larger, larger, smaller method, in this case, again, cups are bigger than milliliters, as you guys can tell from the known down here. Cups are my bigger unit. So I'm trying to convert here from the smaller unit of milliliters to the larger unit of cups. And smaller to larger means we divide. So 500 divided by 240 would give us a decimal that we can just round off. It's 2.08, 2.08, or 2.1. If you round that to the tenths place, that's okay too. Either one, 2.08 or 2.1. But for those of us who want to see the setup method, again, we would simply just set that up as unknown, 500 milliliters over X amount of cups. And then I want to match my units, so I'm going to go ahead and put 240 on the top here, since I want my milliliters to go on top of the known side, and then my 1 cup on the bottom. So to solve, just as we solve all proportions, we cross multiply opposite side of the X. 500 times 1 is 500, and then dividing it by 240 still produces that answer of 2.08. So I hope that helps you guys with the proportions. There's a number of different ways we can use proportions. We can also use proportions in word problems. The great thing about word problems is word problems tell us the known. You may run across a couple word problems on next week's quiz that may say something along the lines of where I give you the known first. If it says a medication comes as 40 milligrams per 2 milliliters. So it's a liquid. I'm going to go ahead and write that down. It's a liquid medication, and the question is telling me it comes in 40 milligrams per 2 milliliters. But then the second part of the question says, well, then how many milliliters do I need to administer if Mr. Smith needs 80 milligrams? Okay, so how many do I administer? How many milliliters do I give if Mr. Smith needs, I'm just going to shorthand this, I'm not going to write the whole thing, needs 80 milligrams of medication. So in your word problems, that's what's beneficial about the word problems, is it tells us the known, and then it asks us the unknown. So we would set it up the exact same way, whether you set down, that known first because it's given to me first, you may choose to do that, or you may write the unknown down first like we've been doing. It does not matter, but making sure those units match up either way. The question told me that 40 milligrams were in every 2 milliliters of that drug, but then I want to know how many milliliters. So again, don't forget milliliters across from milliliters. I want to know how many milliliters do I administer if I want to give 80 milligrams. And there we have milligrams across from milligrams. And we solve it the same way. Since x is down here, I'm going to multiply 80 times 2, which we know is 160, and then I'm going to divide that by 40. 160 divided by 40 would give me 4. So we would administer 4 milliliters, which makes sense. We need to give, in this question, we need to give double the amount of drug that medicine comes in. So therefore we would give double the amount of liquid. So that's just kind of trying to think about it a little bit logically, but we would use the same type of setup. And in those word problems, you'll see stuff like that it'll give you the known. You can use it in a nutritional sense too. If you're looking at a nutrition label, and on the nutrition label it says that, as we know with nutrition labels, it tells us the serving size, and let's say we're looking at a bag of chips or something. It'll tell us the serving size. I'm going to write SS for serving size. Let's say it's about 10 chips. So 10 chips here. Okay, so serving size here is, let's say 10 chips, and we know that on nutritional labels it also tells us the calorie content. Let's say for 10 chips there are, let's say 100 calories, 5 grams of fat. Let's see, chips are always obnoxious, so let's say 550 milligrams of sodium. It's probably even more than that depending on the chips. Blah, blah, blah. But let's say I'm trying to figure out exactly what I'm consuming based on this nutritional label. We can use this label as a known, that it tells me for every 10 chips I get 100 calories. So I could use those two numbers as a known if I'm trying to figure out what I'm consuming in calories. Or perhaps I want to calculate what I'm eating in fat grams. I would use those two numbers. So what I mean by that, let's say that's what I'm trying to figure out. I want to know, based on how many chips I do eat, how many fat grams I consume. So again, our known is the serving size is 10 chips. The fat content, the fat grams were 5 grams in this serving size. But let's say I sit down and I don't eat just 10 chips. Let's say I eat 37 chips. Because nobody just sits and eats 10 chips, let's be honest. Instead, we eat 37 chips. So what we can do is we can say, okay, well, if I had 37 chips, how many fat grams, and I'm just going to write fat grams, did I consume? Well, we can figure that out because based on this serving size, since 10 chips contain 5 grams, that's our known. So we can then just use our normal method of cross multiplication. 37 times 5 gives us 185. Dividing that by 10 would tell us that we just consumed about 18.5 grams of fat. So that is just another way that you can use that proportion method. Anytime you have a situation where you have a known and then a question being asked about that known, so in other words, an unknown, then you can use this same method to try and figure that out. So I hope that helps, guys. You guys do some practice problems with that. Don't forget to do your homework on either the My Math Lab for you Monday students, and then on the Connect for you Tuesday for my nursing students there. Don't forget to do those homework assignments with that so you can get a lot more practice. All right, thanks, guys.